Good evening, good day. This is Engineer Suraj speaking from Bharat, India, addressing the whole world regarding formula generation, mathematical formula generation on worksheet or spreadsheet. This is in continuation to last video which was given before with the same sheet. See, this same sheet was used in that. This sheet you can see here, this Excel sheet. Name of this file is formula demonstration and title is formula generation validation dated 15, 17, 19, 25th, and this is last time we talked of equation 1, equation 2, equation 3, equation 4, equation 5, equation 6, etc., and trigonometrical functions and also certain formulas which last time we talked of, which were various formulas in equations, and then we talked of square, rectangle, triangle, equilateral triangle, isosceles triangle. Like this we talked many one. I have just added to this certain shapes now, and this is the shapes square, rectangle. Then you can say here is also different type of triangle, ordinary triangle. This is ordinary triangle here, and this ordinary triangle, you can see that triangle here. I just pull it and show you. So this is that one, and also this is this is rectangle here, and you go back, and this is square here. You can just pull it and see it's there in this case. And then we have gone to triangle, that is height is given, and it is your isosceles triangle, and this equilateral triangle before that is equilateral triangle, that is this one, equilateral triangle. You can see here this is equilateral triangle, three sides and 60 degrees angle, each angle. And this isosceles triangle here, isosceles triangle, you can see here isosceles triangle here. This is that one, height and sides are equal, base is b. And then this is right angle triangle here. This is right angle triangle here. You can see it clearly. This hypotenuse, this is base, and this is perpendicular. And then we have another one, that is three sides are given, A, B, C are given, and we have this triangle dimension again. This is circle, this is radius r is radius, and this is circle. This was drawn on AutoCAD actually, that's why we're finding different types of copying arrangement here. And also this is now start of polygon. This is a hypotenuse, and this is, you can say, parallelogram. You can say here this parallelogram. Cone I did not write here, cone is different geometry, so parallelogram I have written here. You can see this parallelogram. This is parallelogram. You can pull it and see how it looks further. So you can say base and height and hypotenuse, angles, diagonal, etc. We'll discuss all this. And this is rhombus. You can see this is rhombus, and rhombus is here, and this is rhombus here, where both sides are equal. You can see that. And this is different angles here in this. I worked on through geometry. And then this is, you can say this is trapezium, and trapezium is here. Sorry, this is trapezium, and trapezium is like this. This is trapezium. You can say it's like this. You can see this base is there, top is there, hypotenuse. We have worked out and find of this, and then we can see this. And then we have to another trapezium here, where projections are also available here, and we have to work out in different fashion. And here is now polygon. This is polygon, regular polygon, 5 sides, which is called pentagon in mathematics. And that is, here is pentagon. You can say this is pentagon, A, and we have to find different measurements, parameters. We'll show how. And this is hexagon, 6 sides. You can see this hexagon, A equal, and B and C, all this we'll see how. And then we'll see how is this 7 sides, and its name is heptagon. 7 side, hexagon was 6 sides, and this is here, this is all 7 sides with general calculations and angles we worked out, and all. Then we can say here it's there 8 sides. This is 8 sides. This is octagon. We can say octagon. This is octagon here, 8 sides, and we have to find different dimensions that we did. And now it's 9 sides, and that is nonagon. nonagon, nonagon, nonagon it is. So 9 sides it is. You can see 1 to 3 to 5 to 7 and to 9, and that's it. And we have to find then octet. Then you can say it is decagon, 10 sides. So far I have taken only 10 sides. We will increase later on. So this is your 10 sides. All A and various calculations are there. So this is a program so far I worked out. And this means there are so many other shapes we'll do later on. So what's that remind to you means what we did so far. So just for a review, what we did was there, and what we have done so far, that in equation 1 we have used this ax square plus bx plus c. We worked out formula for this, and by trial you can find various values. And these yellow highlight areas are open cells is written. Other cells which are not highlighted, they cannot be used. They are automatic. You'll get values in those, but this is yellow area, highlighted area is open. And equation 1 was x cube plus bx plus c is equal to 0. Similarly, equation 3 was ax cube plus bx square plus cx plus d is equal to 0. Then equation 4 was wl square over 8, which is simply supported bending moment in engineering, it's theory of structure. And then equation 5 was wl square 24, it's also bending moment of fixed beam, fixed at both ends. And there was equation 6, complex 5 brackets, so we different a formula was generated in which many brackets were used. For example, this is that bracket and this is that bracket and this is that bracket. You can see so big formula here, it is complicated formula. So this was used, and also again this was further extended with different values. And then so equation 8 was trigonometrical functions, where we try to find out values of sine, cos, etc. And I can just put it in, you can say, let us say in single digits, so that is easy for everybody to understand. And we can also put here various values in this. Hold on, sorry, so I can say we just bring it down to 2 decimal places, so that it's easy to understand. Sine square theta plus cos square theta is 1. This is a trigonometrical value. So sine square theta and cos square theta, sine value, cos value, and sine square value, cos square value. So sum of this is this one. And then sine 45, cos 45, tan 45, cos second, all these values are there. We just worked out. We'll see later on, just that day we did it. Now formula 1 was a plus b into a minus b is equal to a square minus b square, and this is complete calculation of this. And similarly, formula 2 was a plus b plus c whole square is equal to a square plus b square plus c square plus 2 into bracket ab plus bc plus ca, and in the open cells value. And this complete formula here, it's like that, it moves like this. You can see whole formula here, and true and false are given there. Then formula 3a plus minus b whole square plus b square plus minus 2ab. And this same way, it was all given like this, means there is hardly one variable cell. That's called open cell. The formula 3 is there. Then you can say here similarly formula 4 with various values, a plus b plus c plus d whole square, and a square plus b square plus c square plus 2 into a plus ac plus ad plus bc plus bd plus cd. Open cells are these. And you can see we had worked out successfully these formulas, though this string is getting longer and longer because there are many variables and many rotations are there, many parameters are there. So these are now we're going to start geometrical formulas, geometrical shapes, which we did that day. We did successfully for many formulas, and I could show this on AutoCAD, but in this format of Excel, AutoCAD cannot be demonstrated. I just stop with this and do it again. So I will not going to show you AutoCAD. Later on I will show you, not in this talk. Now square it is, and we say square is always a side, and that's the 4 sides are equal. So area, perimeter, diagonal remark we can find out here. I explained to you previously also. A square is area, and 4 into A is perimeter, and diagonal is 2 into A square under root. So this is diagonal because a square plus a square is 2a square, and this is 2 square under root, and this is square pyramid. Now we consider this a square figure, superficial figure to pyramid, that is 3-dimensional, and volume is meter cube. So area we have, and height we have. This is height, for example, so we multiply this with that, so get that one. And the surface area is equal to means we have both ends of this pyramid plus surface vertical area. So 2 into square area plus vertical surface area. So this is, for example, that one. 2 into this area, sectional area, or you can say surface area plus 4 into this parameter. Means here these are 4 sides, and see this is 4 sides. Parameter is 4 into a plus a plus a plus a, 4 into a plus a into height, which is this one. So we get surface area per square meter, and that is for ordinary square. It's there. You can see this ordinary square. So now we move on to rectangle. I'm just refreshing it, means what we did in the past, so that you know how we are moving. So that from very simplest figure we are moving on to complicated figure. So this is a rectangle now. L and W, length and breadth are there. Rectangles A and B with 2 values are there. So area is this into this is that area, and perimeter is twice into A plus B. Sum of these two sides is 2. That is a parameter here. Diagonal, same way. A square plus B square. You can say this is square plus this square into root. So that's this one, and we get divided by that's diagonal under root. That's under root here, and we got this value, and the mark is now rectangular pyramid is the same thing as we did in the square. You can do 5 meter height, for example, and we take this is volume and this is perimeter, sum of two sides into vertical surface. And these are all variables. For example, I change value of 8 here, I make it 5. So this whole will change. If I make 6 here, it will change. That's the whole purpose of this, means you are not to do again and again same thing. Once formula is realized, means you can use this formula millions of times. You unlimited number of times you can use this formula. Once you formulate that, that's important here. You don't need to change anything. And then we go on to rectangle, same thing, we can change anywhere. Square, rectangle, you can make it 10, so let's say 12. So you change, complete change. If you say this is step back. And same way, if you say 5 is 8, you change it, that's back, So that's general for us. Triangular ordinate. We're talking of triangle, it's a complicated figure, because only figure. Triangle is much more complicated than rectangular square. It's really complicated one, we have to understand that point as well. Well, I can say here, means why I say here triangle, ordinary triangle I'm talking. Ordinary triangle means it's like that, you see. This is what I showed you before as well. This is ordinary triangle where base is given, height is given, no angle is given, nothing, no sides are given, only base dimension, height is given. You can find out formula for this, and formula you know it very well. So what I say, base is base, whatever value, doesn't matter. Height is 5, height is that height I talked of here. The vertical height of the surface, that's this one. And we do h, so we get a half base into height is formula in geometry. Half into base size is triangle area formula. So this is that half into this into this. Apex is at C, whatever the height of x, so it is apex at C. We're from left base now. Question is, the point is we have to see from this way and this way. We have to find some parameters so that we know where it is. This is for many reasons, because we have to find parameters for the purpose, that. So we'll say, let us say it is C, somewhere here, from apex at C meter from left. Now what does it mean? It means, which you are not seeing here, but it's there, Say it is B here, let's say apex from here. Let us say from this, and is this not, it's not symmetrical triangle, so we can say any value here. That's value C not shown in this, but it's there. So I can say, we assume the value of C somewhere here from apex location. So then there is a D from other side. So this is C from this side, let us say from other side is to B is total base, so B minus C is from other side. So this value is parametric. This parameter is open, while this parameter is automatic. By calculation will come. Now we say left hypotenuse and right hypotenuse. We have to work out in that triangle. Left hypotenuse, left hypotenuse. That is, we have to this hypotenuse have to find. What is hypotenuse? This one and this one we have to work out from this. I did not mention C and B here. You just assume that it's given. I missed that one. So I say that. So these two values are there, and we have to find hypotenuse. So we have to find left and right hypotenuse. H1, let us say H1 is left hypotenuse. So that is hypotenuse diagonal, inclined side, that is. So you can say C is 1 and C square plus H square height square under root. And similarly, this is D square plus H square under root. So this value will come H1 and H2, this hypotenuse will come. So perimeter we have to find. We can say base we have, H1 we have, H2 we have, these two hypotheses we have. So we get this value of base here. That's main point here, base we got here. So we can say So we have parameters now because we have this V1 B plus H plus 1. And remark again almost, now we are talking about parameter. This we got area here by half into base into height, and we got perimeter by calculating hypotenuse, both left hypotenuse and right hypotenuse, and this summed up base plus hypotenuse. We got perimeter here. Now we move on to this pyramid, means three-dimensional shape, height, whatever it is, let's say volume we have end area into height, and that is this one, E75 given here. E75, this is the area, so area into height is here, that is L75. So this L75, we get surface area and we got volume here, and surface area is twice end area, twice into end area plus J75. J75 is parameter of this into height, so we get surface area. So we got all formulas here, so we can check anytime. Let's say 10 plus of 10, I say 20, we'll get complete change here. Height, let's say 6, I make it here, so we'll get change here. So that's what we can do here. You can vary whatever dimension in yellow cells. You cannot touch these cells. These are automatic and calculation tag. You have no right to change them. If you change them, you will miss formula. You will destroy formula. Mr. Jolly Kumari, thank you very much. Thank you very much, Jolly Kumari. So I say welcome and thanks. Okay, I should welcome her and thanks. So we continue now with this one. Let us say some signals from Coca signals back, no problem. Now take an equilateral triangle. I'm talking now, not only triangle. Equilateral triangle, you know what is equilateral triangle? This figure clearly says what is equilateral triangle. This says means this is three sides are equal. A and these angles are 60, 60 because sum of three angles of the triangle is 180, so 60, 60, 60. A is there, and that's what I should say this equilateral triangle. Now, what to do about this? In this, there is the number of sides are 3 less than now angle is 60 degrees less than now. It's the 60 degrees, and I think equilateral triangle. So it can't be less than 60. It is 60. Now number of sides are 3. Now degree H, 3 angle actually it is. I should say angle, so the confusion is avoided. I don't want confusion. 3 angle. Now 3 angles equal to 60 degrees each. Open cell is this. That's a 5 dimension of A. This A1 here. Now question is what is area in equilateral form? This is 3/4 into A whole square under a square. So this is area here. We're going to do formula. This is the formula here. So we got this area C80. C80 is this one. So we got this formula. Parameter, you understand, A plus place of 3. So 3 into sides parameter. Now equilateral triangle pyramid. So this is very easy. You know this formula 3 of finding area. Not a big deal. And if you want to find geometrically also, we can do that. We just draw a vertical here, half and half, and half into base into height. We find that is the problem. Now equilateral triangle pyramid, same thing. Area we have here. This area we have. This is here. So this is D80. So D80 into G80. This is G80. We get volume. This cubic meter, and here also we get surface area 2 into end area. So this is 2 into end area. D80 is end area here. 2 and plus parameter. E80 is parameter here. That is say here E80. This is parameter here, and G80 is depth. So we get surface area. That's equilateral triangle. I'm just repeating. I'm just giving you a reassessment. We have already talked all the isosceles triangle. We have just seen isosceles triangle. What isosceles triangle is all about. Two sides are equal. These angles are equal. Base is different. That's what height is there. These sides are equal. These angles are equal. This is called isosceles triangle. And both sides are equal. Open cells, base is 10 meters, base and height is 15. We can change whatever. Half into base into height is square meter area. So this is half into base, so this is half into C85 into D85. You can get this triangular area. Now we say in this we say we just 0.5 b square. Let's say h square. All right. Now hypothesis is defined because that's point. There's a base, just very hypotenuse. You can say base over 2 because this is base over 2. we have to find this hypotenuse, for example. So this we have to take, this is a right angle triangle here. Now this is also right angle triangle here. So this square plus this square is equal to this square, and this square plus this square is equal to this square. Hypotenuse base, half base into height. There are two things, half base square plus h square under root is equal to this. This is hypotenuse solution. Find a hypotenuse. So perimeter equal to base plus 2 hypotenuse. 2 hypotenuse are there. This is one hypotenuse, and all the sum of this is, you can say, that's called perimeter. So we have to work out that one. That's important. Parameters 40 is coming here, being to 2h. H, it's not height actually now. H is there, but that is hypotenuse h is and height h. So we have something confusion to be removed. So 2 hypotenuse, let us say this for clarification, 2 into h I can say rather than h, because this will cause confusion. So 2 into hypotenuse, and hypotenuse is equal to h. Let's say this base is there already. Base is base, so this is h. So hypotenuse is equal to base. Now why to find hypotenuse? Base, half base square. As we said there, half base square. That is half base square, and this is square. Let's say half base square plus height square. Height square under root. Under root means 2 power 1 over 2. So that is here. We can say sum of F85 and this one. Here we had calculated 0.5, half base square is here already. We worked out separately this one and this one here, and h square is here. So for half base square is there, half base C85 square, and height square is here 85. 85 is here. So sum of this is here. Sum F85 and G85 is here. So we got this one, and perimeter. This is your under root by power and 0.5. So we got here. What we got here is we got hypotenuse here, big h, this value. Perimeter, now perimeter is base plus twice into hypotenuse. So this is that base is C85, base is C85 plus twice D5, twice D85, and this is twice D85 is here. This is the height, so twice, not D85, is something, D85, this is height. But we have to say this height is there actually. Let us say, sorry. It's cold. Sorry. So B into 2H. So BH is 2 into D85. H is this one. So this H85 actually. This one is that. This is hypotenuse. So this is this one. This is this one. So we can say this is that one. So we just bring it to single one. This is that one. Why say perimeter is equal to base plus twice into hypotenuse, and perimeter is B. B is here. B is here. C85 plus twice is here, and H is here. This is hypotenuse. This is H85. So we get this value B plus into H. This is perimeter. Now vertical. Now in pyramid we can say height is 10, volume into volume meter cube. Now volume is this, let us say this is area here. Area is here, it is E85 is area into height. This is height K85. We got this one. And now surface is total surface, I mean to say. This is twice into end areas, means your triangular areas, twice into end areas plus perimeter into a height. A height means depth. Perimeter into depth, you can say. Depth rather than height. Depth, you can say. Whatever depth of that is, we can say here 2 into E85. E85 is this, which is area. So twice area plus we say perimeter I85. Now perimeter here is, this is perimeter, this is I85, and K85 is here. So this is your total surface area. So we can put it to two places of decimals. This is perimeter and this is that one. That's required of isosceles area, and it's pyramid also. So it is pyramid of prism, you can say. It's a complete straight depth without any angle, without slant, without something. So this is now, let's go to right angle triangle. Right angle triangle. Just going very fast for the fast calculations, because I just want to refresh everything which we did last time. It's mathematics. It's not easy. It takes time, so I'm just giving it back up. So right angle triangle we are talking of, means it's not means right angle means 90 degree is one here, you know that. This is you can say yes, this is here hypotenuse. Another thing that is coming in, base perpendicular hypotenuse. This is 90 degree, and this sum of two angle is also 90. Sum of two angles, so total is 180. We'll do now right angle triangle. Base is B, perpendicular is P. This is B and this is P, right? I will say area. What's the area? The half into base into perpendicular. Okay, half into base into perpendicular. So this is half into base is C90, and D is this. So we got this area. We got hypotenuse, base square plus perpendicular square. That is base square plus perpendicular square, and the root is hypotenuse. So let's say half into base into perpendicular. So half. That's this area. Sorry, hypotenuse now. Hypotenuse is this. Now C90 is base square plus D90. D90 is perpendicular square under root. This under root we have write like this, but because of the power we can say 0.5, whole square to power 0. Whole to power 0.5. We got hypotenuse 20. Perimeter. Now perimeter means we have to calculate these three sides. B plus P plus hypotenuse. So it's very easy. B plus P plus hypotenuse. We get C90 and D90 and hypotenuse F90. So you get this perimeter. Now we have got area and perimeter. We want third dimension, solid volume, and let us say a vertical dimension 8. We can say here E90 is area multiplied by this I90, which is area multiplied by height or depth. We may say height or depth. We may say I'll say depth. Better pyramid depth. So we can say depth is 8. Their volume is and area into depth. You can say depth. So it is this much. Surface area, this is now volume. Now we say surface area for twice and area plus perimeter into depth. Let's say like this, okay? So this is 2 into end area E90 is this 2 into end area plus G90 is perimeter. See, is the equation twice into end area plus G90 perimeter into I90, and I90 is depth. So we get total surface area here is that. So we get third dimension of vertical projection, vertical extrusion of this surface area. This surface equilateral triangle vertically extruded, and we get surface area and volume here. So this is right angle triangle. Now you can make changes if you wish. Let's say 15 and 30. Let's say 30. We get again changes, and let's say this 15. We get changes here. So we can use it whatever number of times, doesn't matter. Now let's go to triangle. There's a right angle triangle. Now I'm going to right angle triangle. Now I'm going to triangle with 3 sides. This is a very complicated one. This is triangle with 3 sides. When dimensions, 3 dimensions are given, and this is what we have to see, which is very usual case, but good one. This is that these 3 sides are given of this triangle. You can open it, blow it. A, B, C are given here. No angle is given, nothing given. Only 3 dimensions are given. Let's say 3 sides, side A, side B, side C are given. Let's call it side 1. That's A, side 2, B, side, let's say 1, 2, 3 like that. A plus B plus C is equal to divided by 2. That is formula of S, S into S minus A into S minus B. That's general formula for area of this triangle. 3 sides are given. That's S is equal to A plus B plus the sum of 3 sides divided by 2. That's formula here, which is given here. And we have to find this S minus A equal to 1, S minus B equal to 2, S minus C equal to 3. And area is S into 1 into 3. So 1 is S minus A, S into S minus A into S minus B into S minus C. Under root, that's called area of this triangle. This is general formula, basic formula where nothing, no angle is given, nothing is given, no perpendicular is given. Three closing triangles, there are three sides. We can say this value is S, this is C96 to E96, C96, D96, this is, and half of this is called S. So area square meter, S minus 1 is equal to, this is 3, this is S minus A. As we have, this is S. So this F96 minus A, and minus A is this. This is 96 minus C96. In other cases, D96. In this case is this E96. We got 3S minus A, S minus B, and minus C. We got formulated, means we can't change this. We can change this whatever. So we got half formula here. Now we say area we have to find S into this and this. So we say that S F96, this is S F96 into H96 S minus A, and this is I96 is S minus B, and this is S minus C, J96 S minus C. So these are three. So we got S into 1 into 2 into 3 wholes under root. We got this item as area. Now area we have, and of course perimeter we have is simple one, means I think I use base height S plus A plus B plus C is equal to this square meters. This is area, and of course parameters A plus B plus C itself is parameter. There is not a confusion here, we know that. The three sides are there, so the question of A plus B plus C is spell parameter. If I can add, I think it's better. Area is there, parameter I think is the given or not. Let's see. This is surface area. Yeah, parameter is there, and this is given 2 and area plus parameter H. So it is given. Let's say first of all, let's finish this triangle, three sides, and we can say height, whatever we can say, and volume is this height multiplied by is K96. K96 area multiplied by height, you can get volume, and surface area, that is 2 and area plus parameter, this is that one, and the other surface area 2 and area plus parameter H. Perimeter into H means perimeter to depth, actually it should be. I've written H, no problem. Vertical height, so it's written vertical H, it's capital H, and also it is capital H here, which is given by this. So we got this answer here. Now see how it works, and area into H. So K96 is area, and H is that. 2 and area is this. 2 into K96 plus perimeter into H. Perimeter is D96 plus D96. So D96, and this all three dimensions are, you can say D96. Let us go to D. D96 is D96 plus E96 plus F96, which is your BC. Hold on. I think maybe something wrong here. Let us be clear. Parameter we have to find like this, right? So it's better if you take parameter here. Parameter, if I just put it, not a difficult case. The square meter I want a parameter here. We just put in here and just space here. So we can say parameter here. Perimeter, meters. So parameter meters very easy, and that is formula is A. That is A plus B plus C, right? The sum of three dimensions are there. A plus C plus D is very easy, and that's meters. So we say meters. Doesn't matter. Let's say A plus B plus C. So we can say A. Sorry, not this. A plus B plus C. A plus B plus C. Yeah, it's here. Yeah. This A plus this B plus C. So this parameter here, we got parameter 16. So we get parameter 16, and this is here. Now we can directly apply this. Now in this case, we have volume, surface area is this, so perimeter into H. Now what is that? Let's see, twice into area, twice into K96, twice into K96 is that area. It's okay both hands. Now perimeter into H. Now let us say perimeter is here. This is perimeter into H, And where's h? H is here. So we get this one. Parameter is 2 into k. Let's say we can bracket also for clarification, though no need, but to keep it separate we can understand that is there. So 184 was here, and again it's 184. So we have twice into surface area, that is the figure area, 96, K96 here, plus L96 is A plus B plus C, this parameter, into M96 here, this is here height. So we got 184 here area. Now surface area, 2 and area plus perimeter is okay, fine. This is 2 and area plus perimeter. This is total area now, surface area. This is 2 into area plus, again it is repetition, doesn't matter, means something else it is, I don't know. I should not keep it like this. Surface area is equal to meter, 2 into and area plus perimeter into h. So I think this is something not required. It's given here by chance. What is given here? Let us see. 2 into K96 is into area plus sum into D96 F96. D96 F96. What saying is D96 into F96. D96 into F96. This is not that one. Hold on. This is not that one. So this is by I'll remove this. Let's say delete this one. Just not to confuse one. And I should know. That's what means here is this, and here is that one. So we can put this figure here just near this. So this is about 3 sides. Now let's change 15, 15 or 14 or 20 or 25. Let's say this is that one, Let's say this is that one. So I say 25 here. So you will get, ABC is 30 and square area is now, square meter area is all changed. That is, perimeter itself is 60. Yes, it's 60, so all change, and here also it changes. 15 comes, and now let's say 15 height is there, so it changes also this. So it's come working this way. Anyway, it is a 15 plus 20, 35 plus 25, 60 it is, and area is S minus A, S minus B, S minus C. So we can say here is S minus A. For example, S is 30 here, 60 or 230, 30 minus 15, 30 minus 20, 10, 30 minus 25, 5. So it's working. This means, so we say triangle of 3 sides is over. We have 1, 2 triangle 3 sides. Now let's see other one, that is circle. Circle is very common, circle width. And it's nothing with the radius is given. This is circle, the radius given is nothing very complicated. Last time as well. What's the radius is r here, and with pi, this value of pi, you can say pi, this is formula of pi, you get value directly from computer. So add pi bracket or equal pi bracket, you can this value. And area is pi r square, so this is D102 is pi, and r is this one, pi r square, and coefficient pi r square. So we can say coefficient is, now we will find coefficient for this for area, and this is for circumference area. Now don't call parameter circumference for this 2 pi r, 2 coefficient I kept here, and pi r, that's a, what's it, 2f102 is coefficient into pi t102 pi, and c102 is radius. So 2 pi r, you get this value. Remark open cell is circular. Now about pyramid of this, let's say 3 dimension one. Height is, let's say 5, and volume is, let's say, and area into h, and area is 10 E102, that is E102 pi r square into h, and this is hi. So we got this one. Now surface area is twice into and area plus circumference into h. So this is h, this is h here, depth or h, and 2 into and area, 2 into 2 is there, E0102 is and area plus perimeter is now, circumference is this, G102 into this is I102, you get surface area, total surface area. So we got this solved. We can just put now as 25 you keep, you will get complete change, and that's what is required here. So demonstration of this is over, and I can say Then I can put it here linear. Now, surface circle has gone, so is now sphere. Sphere, which is a complicated one, is different formula for us, and we have to follow that formula. Sphere, let us say radius of sphere. I didn't make any diagram for this. You know what is a sphere? It's a ball. Earth is a sphere, and radius is 25. Let's say pi is same thing. Pi bracketed, and coefficient formula is 4 over 3 pi r cube. This is volume formula. Volume of sphere, surface is 4 pi r square. This standard formula. Volume 4 over 3 pi r square, we need 4 over 3 here. Coefficient to keep here. And pi is here, r is there. So 4 over 3 pi r cube, let us say. E108. E108 is 4 over 3. Then pi is in D108, and this is C108 is r into volume of cube here. This value of cube, and we get this answer. And if you take it in bracket also, so that you will be clear, so it can be done like this, doesn't matter. So it's same thing as it was before. So pi 4 over 3 pi r cube. We get volume, and now we get surface area of 4 pi r square. That is 4 pi r square. This is surface area. Coefficient is 4 here, 4 pi r square, 4 is coefficient. And here you can say, let us say 4, that is G1084 is there. Pi E108, E108 is pi, this is E108. And R is here, R is this one. This says C108, that's square, pi r square, we get this value. This is surface area for. Now hemisphere we are talking, hemisphere, half of this, we cut surface area exactly through center. You'll get hemisphere half of sphere, which is a little different one, because it will affect volume is the half of exactly sphere, half sphere volume. So we can say half of 0, this is volume here, so exactly half it is. But surface area is half into surface area plus circle area, cut section circle area. So we have two values here, half into H108. H108 is square, this is surface area. Half of that is surface area plus sectional area D108, and D108 is here. D108 is pi, and r square, circle area is pi r square. C108 is radius, so pi r square is circle. This area is circular area, and this area is half into volume, surface area. So we added this one to this area. So we got this value here. So we got correction. So surface area is not half exactly. It is half surface area of volume of a sphere plus cut area. But volume is same, surface area is different. Remember, surface area of hemisphere is more than half of spherical area. Now we go to cylinder. Cylinder, you know very well, a cylinder circle is there, and you just extrude it, you'll get cylinder, right? Extrusion, you know, in AutoCAD, extrusion. So cylinder, radius is there, height is there. Radius is there, height is there. Now this height is vertical one. Oh, no problem. There's only one height in cylinder. Circle, the circle doesn't have a height. So 15 into 20, that's the 15 radius, and height is h. Pi we take here, because the volume of pi is there. Coefficient is, why I'm taking coefficient, because volume you have to find first of all. Pi r square h. This is volume, and curved surface vertical state of volume is pi r square h. Here you coefficient, that is 2 in pi r h. Pi r is curved surface vertical area is pi r h. Pi r is 2 pi r is circumference, and h is height. So here we can say pi circle, it is coefficient, that is 2. This coefficient we are talking, and now we say what's volume? Volume is pi r square h. Now what is pi? Pi is there already. That's E114. R is C114. This is C114 whole square into height D114. This is height. So we get volume. So simple. Volume we have. Now let's go further. This volume is over. Cylindrical volume we have. Now we have a curved surface of cylinder. Curved surface volume. And what's that? Let's say curved surface volume is 2 pi r into h. In circle, circumference, and curved surface vertical curved surface pi 2 pi r h. Pi r pi d, or you can say 2 pi r is circumference, and h multiplied by that. So 2 g, when we put 2 here, we can take direct also, we can take log. Now just to explain to you, 2 g14 is 2 here, e114 is pi here, so 2 pi r is c114, that is here, h is here. So we put all this and multiply, we get this volume square meters. The curved surface vertical. Now circle, pi r square, two-end circle we have pi r square, this is pi, pi is here, e114, r square, r is here, c114, we got square here. Circle, so total surface area is sum of these to 2 pi r h, 2 pi r h plus 2 pi r square, plus 2 pi r square, pi square is circular is twice that. So we can say that is one is this one here, I14, other one is this, sum of these two is this, total surface area. This is formulation of cylinder in 3 dimension. Then we go to cone. Cone, you know cone, everybody knows cone. Volume of cone is 1/3 multiplied by pi r square into h. This is a formula. Radius, you know, r, h is 20. Coefficient, we know, become this 1/3, this coefficient 1/3, and this pi coefficient here. So volume is called the cubic meter half pi, that is pi r square into h. No, we have the coefficient is called the coefficient we have to take. So F190 is the coefficient here, 1/3. That's I think it is a mistake here. Volume is equal to 1/3 pi r square h. Already is there, so it doesn't matter. So let's say this coefficient, we'll put F119 here and D119 here, which is r. See F119 here, coefficient 1/3, then pi. G119 is pi, and D119 is radius square, and E119 is height. So we got this, right? This is volume. Now circle area, how much? Circle area, which is one circle only, pi r square. So this pi r again is the G119 here, pi r is there, D19, 119. So we got this circular area here, and curved surface, pi RH is called value 1. Now curved surface value 1, value 2, value 3 are there. Pi RH, that is 1. Then pi R1, so value 2. Then value 1 plus value 2. This is pi RL actually, pi into R into L. This is slanting surface of cone. This is circular surface of cone. This slanting L, pi into R into L, value 2 this is. So we have to make two values together, 1 plus 2. Now, but what about this L? Question is that we have this value pi RH. Let us say pi is here in this J119, and then R is in D. R is here, and you know H is here already. That is H. That is in. What's that? Yeah, this is H. Here is H. H. This is in E119. So we got 1 here. Pi RH. We got here value 1. Value 2 we have to get, and that value we have to see how we have to work here. Total surface area is equal to pi r in length plus height, this formula. So that's the length is equal to, we have to find this slanting length actually. It's nothing else, slanting length, inclined length of cone. That is r square plus h square. R square plus h square under root. So let's see what's r square. R is here, this is D119 square plus h square, and that is E190 square under root. So we got 20.62, that is slant inclined, and we have now find this pi r length. This is, we got this is total surface in pi r into length plus this. This is, we get this here G119 pi r, this is here, G119 into D119 is r pi r, and N119 is this inner slant one, and height is E119, that's h. So we got this value, and you see this sum of these values here which you got through this value is this one. So total surface area is this, a formula, and this we got, so it's validated together. We got it. This one value, this second value, this value, and this also direct value we apply, we got this value. So both are equal. So we validate cone also. Now parallelogram, which we are waiting for. These formulas we took just before. I just refreshed them. And now we are moving further on parallelogram. Parallelogram, then it would be rhombus, and then it would be trapezium, two trapezium, 1 and 2. Two means offsets in one equal, other one you can say one is symmetrical, other is non-symmetrical. Then will polygon regular, we'll see in polygon, in regular 5-sided polygon, 6-sided polygon, and then we'll see 7-sided polygon, and then 8-sided polygon, then you can say 9-sided polygon, then 10-sided polygon. So far I worked on 10 only. Now let's square. Let's now start with parallelogram. What is parallelogram? Question is this. Why we worry about that? It's a geometrical figure, and we have to see that one. It's very important point, That is parallelogram. Parallelogram. Unfortunately, I have this copied from AutoCAD, and that is what is program is. You see this one, this parallelogram. This parallelogram, you can see in this there's a base, right? This is a hypotenuse. This is a parallelogram, and you can say in this what's given is parallelogram. There's base, then height, both are there. This means this is h, height, and this is base. This is the two-dimensional figure. Planar figure is on horizontal, placed horizontally, and vertically not. It's a horizontal figure, planar figure. So base into height, and this is, of course, this angle we don't know, this angle we don't know, diagonal we don't know, diagonal we don't know, but base and height are given. This is parallelogram, and we have to find its details, what we do, how we do. Let us see. Base is here, height is here, angle, let us assume it is 45. Which angle it is? Let us assume it is 45. Let us say this is 45. Means it can be whatever you can take. But now, because we are formalizing this, to enter into formula, to fix it for further calculations, we assume now this is 45. This is diagonal 1, this is diagonal 2. So let's go further now. Now we have to be very concentrative on this. Now let us say H, that's perpendicular, P is 4. So this is 4. Okay, we just assume that. Given angle value is 45, let us say, it can be 50, it can be 60, it can be 30, depends. But now we are taking 45 for purpose of our calculation, so that it is properly formalized. And what you say area square meter is base into height. So base is here C124, C is 124 into D124, height is D124. We can find area directly. There's no big deal in that. But we have to find hypotenuse, and we have to find twice into A plus twice into hypotenuse, that's perimeter. If this area we got perimeter. If you see perimeter, this is this plus this and plus this. This perimeter. Base we have, height we cannot add in perimeter. This means we need this information, right? We need this information, we don't have. We have only this information and this information. Others we have to work out how to work out. That is the point here. So we say twice into A means A is base dimension, as I said. This is A, twice into A. Let us say this is twice, and twice into this hypotenuse. If you sum up these two and sum up these two, we can get perimeter. This is very complicated. Be careful, but be concentrated on this. Not the easy one. It looks easy, but it's not easy. So we say twice into A. Twice into A. This is twice into C124. Twice into C124. That is A plus twice C into 130. Twice C130. This is 130. Here we reached here by calculation. This is not automatic. It's not given. Here we are stuck up. We shall be stuck up here. How to find this? That's an important one. And then, of course, so these are parameter answer, but we have to work on this. Now, diagonal. What about diagonal? These two diagonals, these two diagonals. What about diagonal? This diagonal, I call it diagonal 1, right? I call it diagonal 2. There are two diagonals only. These are not hypotenuse. Hypotenuse this. I'm calling this diagonal. Let us say these diagonals. It's very important one. We have to find diagonal 1 first. So for that, I will draw the perpendicular here from this corner on this diagonal. I draw a perpendicular here. You see this perpendicular here, and I draw another perpendicular here just for purpose of geometry. Let us see how it works. Now it says that diagonal have perpendicular from left top corner to diagonal 1. An angle shall be half of value. Which angle shall be half of value? You can say this angle here. When you join this diagonal, this was 45 for example, and this will bisect this. You will find both angles equal here and here, and you have perpendicular here. So you have a diagonal here, and you have h here. We have to work out both. We have to work out this h, and we have to work out this, or we have to work out this, and we have this hypotenuse. Means we have to find area of this triangle has to be used. Area of this triangle has to be used to find diagonal. That's what's requirement. And for that we need h. H we can do. Now how to work on that? That's point here. Geometrical calculation it is. So how perpendicular we have done it from left top corner diagonal 1. Now angle shall be half, that I told you. Now because it is half, so it's half of E124, so 45 years, so naturally it's around. Now perpendicular from hypotenuse, perpendicular hypotenuse sine half angle. Now what's what I'm talking? I'm talking of this half angle here, right? This angle is called this angle, this half angle. So perpendicular upon this hypotenuse is called the sine of this angle. This is because the h is perpendicular on this diagonal. This is perpendicular. This is hypotenuse. Perpendicular upon hypotenuse is called the sine of this angle. Is very clear? Perpendicular or hypotenuse sine of this half angle. Now perpendicular we have so triangle height. That is perpendicular we have triangle we have is equal to triangle height. That is, what is that? Now we have to sine, we have to use here from let's go back and see how to work on this first of all. Now let's say this 45. Now this sine angle, this cos angle, this tangent, basic angles in trigonometry, and one over those of those, that is, so whatever value I get here, I reverse that here. Whatever I get here, I reverse that here. What I get here, reverse that. So you'll get cosec, sec, and sine. Reverse sine is cosec, reverse cos is sec, and reverse of tan is cot. So these are values, that is trigonometrical values. You have to understand this first of all. Let's say what sine angle of 45. This is the only angle we are using. So sine 45, sine E120, E124, E124. This is here. Sine E120 multiplied by pi bracket over 180, because they have to directly bring it to degrees, not to radians. So we are going to work in degrees. That is 360 degrees equal to 400 radians. So we can say 1. We can bring it by that. For that we have to multiply with pi bracket of 180. So this is the value of sine 45. This value of cos 45. You must have heard both values are always equal. Sine 45 and cos 45. So it's automatically doing this. Tangent is perpendicular upon base, and this is E. Tangent of this is automatically, if you divide sine over cos here, we get this, but we are applying formula tangent E124 and same pi over 180. So we have this value, so we got reverse of this 1 over E26, and this is 1 over 2 E27, and this we get values here. So we have got these 6 parameters here, these trigonometrical parameters. This is very important. This will use everywhere here. Now what to do? Now a minus x is equal to p cot angle. What is a minus x? Basically say x a. We are saying x something else, means a minus x. We are saying what is that x? That's the point here. Now because we can say, let us assume now this is now D124. D124 is, that is, A1 is equal to P. This is, say, H is equal to 4. D124, F128. D124 is here, and F128 is here. This is tangent, this is that one. Now, cot is value of cot. By using this value, by using these values, we get answer here. This is A minus X. A is C124, 127, sorry. This is C127, 4. We brought that 4 here actually because we are taking here, we are working on this triangle. We are working in this triangle now. This is a right angle triangle here. We should draw a plumb. We draw a right angle onto this diagonal. So we are talking in this world now. H is vertical. Now we have to find values here and here because we have to find values here. This angle is there and we have to see how it works. Oh my God, why this drawing has come up? Sorry gentlemen, just a minute. Let me bring it back. Hold on. There's some drawing automatically open. Let me close drawing because it will disturb otherwise. It will disturb. Yes. I'll let you close drawing. It's open by mistake. It came up, so it disturbed this process. Where I was somewhere. Where I was actually. Polygon regular. So there was some disturbance here in this. Some disturbance was here. I think it is this one. Yes. So that drawing interfered. So now again we are back to this one. So what we got actually, we have to find this hypotenuse. This hypotenuse we have to find. That is this one. A hypotenuse, both are equal here. This hypotenuse we have to find. Then we have to, actually we have ultimately to find this diagonal because this area we have this parallelogram area is half here and half here. Diagonal we don't know. This H we have taken. This we have. So let us see how. No, my God, disturbance is too much. Quick heal, go, don't disturb. Okay. My God, updated successfully. Okay, right. Now, what I say now, let's say hypotenuse is, let's say there is this C124, this is this one, C124, this A, minus C129, C129, that is this one, X, whole square, plus D124, D124, that is H, perpendicular, that is, perpendicular, that is, D124 whole square, and under root this. You got it? Formula is to find this, to find H. Given angle is 45. So what do you say? This is C124. This is here base minus C129. C129 is value here. We got C128. C128 is here. See, we got this one, and hypotenuse comes out to 5.66. We have all these values here. Now what we do? We have given values 5 base into H. Base we have, that is C124 into H, and that is D124 here. This H is there already. This is value in that. So this is 5 into 4, 20. Area we have. Area this now per parameter we have to twice into area, twice into hypotenuse. Twice into area, twice into C124. Here I say twice into C124. Twice into C124 plus twice into C130. Twice into C130. This is hypotenuse. So this hypotenuse and this area, this hypotenuse we have, and we can say perimeter is twice A, that is base, into twice hypotenuse. This means we have this perimeter. We have twice of base into twice into this. This is regular parallelogram. So we get perimeter here and area. We have our resultants. Both we have, but that is not enough because we are interested in diagonal. That's important. Diagonal, and we have to verify also that whatever we get, using our formula and this diagonals formula, they should match. That's important one. That's the important point that we are interested in. Okay. So what we say now, we are done. Angle is half. This we have area and parameter. Now perpendicular upon hypotenuse is sine angle. Again I say perpendicular upon hypotenuse is sine angle. Sine angle is known. This angle is known. Hypotenuse is known, and we don't know this perpendicular. So we have one information here. One information here means we can say perpendicular upon hypotenuse is equal to sine of this angle. Perpendicular upon hypotenuse is equal to sine of this angle. So we can say, we can find value of this perpendicular, right? So perpendicular hypotenuse sine angle, right? Now perpendicular we have triangle height. Perpendicular we have the triangle height. Now that is we can say C130 is here. C130 is A, right? C130 is A. This is A, and we have to C130 is A sine. We have to say sine 1 I24. This is I is an angle. So we can say this is C130 is here. This is C130, that is here. This is hypotenuse, right? This hypotenuse. C130 is hypotenuse. Oh, just a minute. Where is I missed here? Yeah, we are working here. So this angle, this is that one. C130 hypotenuse sine I 124, that's this one, and that angle of pi into 180, that's trigonometrical angle, degree angle. We got this. So we get perpendicular. Now that is, we got this value of triangle 2.16 means we got this value by this formula. Diagonal base triangle area is equal to 0.5 BA. Diagonal base triangle. This is diagonal base triangle. I'm calling this. This is diagonal one, and this is his triangle now. Now diagonal half into base into height. That is, you can say half into base. This is half 0.5 into base. This is base, and that is diagonal. Base is diagonal, which is unknown. H is known. And we have now this is known, this H. H is not this H, I'm talking of this H, which are perpendicular now. So you can say area of triangle is half into whole area. This area of triangle, because this is cut here diagonally, this area equal to this area. So we can say this area is equal to half of our area. So half of area means half 124. This is F 124. And this is area here. Area, this is 124, half of this. So 0.5 to this, half of this. That's what it says. So area is equal to 0.5 into whole area. This is this one. Now base or diagonal one is equal to twice area or height. So twice area or height is equal to the formula. So twice M124. This is half is to height, and this is so we can do 9.24. That's what we got here, right now. This is diagonal 1 we are talking, and to be now let's say what actually we are going to achieve. We have here now, we have to find diagonal 1 is here, diagonal 2. What is diagonal 2? That's the point, because D1 is here, D2 is here. That is diagonal 2. Diagonal 2 is area into twice 2 over D1. This is a formula here, D1 into D2 over 2, that is area. D1 into D2 over 2, that is area. So what we say here we say that diagonal 1 is this one. We got 9.24 from here. Diagonal 2, 4, we can go only from this area 20 because this area is 20. So total area is 20. Here we got 20 area, so we just put in F124. f124. So we can know this one. How you know? This over this, n127 over this d1, we get this value. So we got d1 and d2 both together. Now what to do? We go to pyramid, 3 dimensions. We have pyramid, open cell, this is 10-meter height, we can say, depth of pyramid. So, and we can say, so that is volume is f124, that is here f124, area into height is this 127i, so we get volume here, this volume here. So we can see this volume of, and this is surface area is in square meter, which is twice into parallelogram area plus perimeter into depth. So twice into parallelogram f124, this is f124 area plus g124, and g124 is here, it is g124, that is perimeter into I, this is 127, we got this is perimeter. You can see that. So here we solve, we get values of this perpendicular, we found value of hypotenuse, that is because of angle we found that, right? So we have base over 2, or we can say, how we find that, hypotenuse we found this way, c124, which is a, minus c129 here is 1, let's say 1, and this is c128 is here, c128 is here, so this is 1, and we got a minus x, this is a minus x, and a minus x is equal to p cot angle, that is a minus x means whatever value it is, assumed value is a minus what values we don't know, because we have assumed, we don't know what's the, so this base a minus value, cot we got value here, so we use trigonometrical function here, and we solve this problem by trigonometry rather than by, we can directly solve in AutoCAD, but question is how to find in trigonometry, that's parallelogram. So we got complete parallelogram. Be careful about these trigonometrical functions, and that's what parallelogram is all about. Thanks, Mr. Divakar. Mr. Divakar. Good evening, Mr. Divakar Pandey. Welcome. I'm just doing a revision, of course. It is revision, but now it is professional revision, not the cramming revision. We are going through a stage where we have to understand step by step everything. It's that time was different. Now we're going to parallelogram, now rhombus. Rhombus, well, I think it's probably light here. I cannot do full video today. No problem. This is rhombus here. This is rhombus. Rhombus, is 4 sides are equal, A, and A, and angle, and etc. D1, D2, same, and H. And all this is nothing new in this. But before going to this, let me change these values in parallelogram and show how it works. Let us say it is 10, and let us say H is equal to 5. Let us say an angle is equal to 25 rather than 45, 25. So you see everything is changed, right? And let us say 5 here. You can say that everything has gone. Everything has altered here. So this is working. You can say now come back to this, and this working. Means flexibility exists in this. Flexibility means you can not necessarily the 45 you can take this way, or you can take this way, depending on what angle you are taking here. All the angle will come back same, because everything will change. Height you have to specify, that's here, and here we have 4, that's why I changed 8. Rhombus. Rhombus. Again, I remind, we have rhombus in sequence, then we have trapezium symmetrical and trapezium non-symmetrical. Then we have polygon regular of 5 sides, then 6 sides, then 7 sides, then 8 sides, and then 9 sides after that, 10 sides. I have taken till 10 only, but I'll take 11, 12 also later, because it increases volume of dimensions and parameters. So I'm talking only for now rhombus first. Rhombus now, where base is here A, which is all 4 sides are equal, and angle you have to choose yourself, that angle, though it's not given in geometry, but we as an engineer we can assume angle. This is angle here, means this is this angle here, angle is written here. This angle is how much? It depends, because it can be this way also, it can be this way also, it depends also. We are taking angle also as a variable, just like we took their variable 45 here, though fixed, but it can be changed, no problem. It can be changed, and it also same way. It has to change, because this is linked to these, this E24, this angle is linked to in formula, so it will take automatically, no problem for that. I can show you, for example, it's 55, I make it 60, let us say. 60, you can see all have changed. You need not work on that. You can see this, you see, you can see this, you can see this. So this changes itself. It changes each and every value, it changes. So let's go to rhombus. Same way 15, I'm taking it variable, and this is drawn perpendicular, this actual drawn perpendicular. Same way as I did in that case, we have drawn a perpendicular here. H is here, and we have this here. So we can say, let's see how it works, what functions here. Maybe I copied wrongly, so the H is going to draw perpendicular, a cos vertical angle. So a cos vertical angle, right? This is A, this is angle here, this angle. I've not mentioned here, but it's an angle, vertical angle. So we can say, because of 90 angles, the vertical angle A is this. Let's say this is A, this angle. So what I can say, A and this angle. And it's saying that it says, this is here, A cos vertical angle. A cos vertical angle, this is perpendicular, drawn perpendicular. This is A, this angle. This angle will come out base over hypotenuse, so we want to know this. So A cos angle, we get this, right? A cos angle. Because we are taking this side, the base is cos related. We get this one, right? Then it is one formula here. We got, other one is H over B is equal to tangent vertical angle. H already we got, H over B is equal to tangent, and that's what we got here. This is B, we assume this B. With this perpendicular, if you have, we assume this B, and we assume this also B, because this is irregular, and whatever is here, same thing is here, and this is A minus B, because this whole is A, this is A, right? This portion is A minus B. B, if you take, you got my point. This is A in original figure A, this is. So this unknown is B, and this also unknown is B. So this portion is A minus B, A minus B. And we know this is H, so we know this angle. So now how to move, that's point here. So H over B is equal to tangent 90 minus vertical angle. H over B. Let us say H over B. H. This is H, we have H. We have from given dimension H over B, perpendicular upon base, and this is angle here. How much angle is here? This is the right angle, because we do perpendicular, so 90 minus this angle. H over B is equal to tangent 90 minus this angle. So we have, say, tangent 90 minus vertical angle. So this is that value. Tangent 90 minus the 135. 90 minus the 135 by 180, by 180. So we got value of this, got value, this value. Now area square meters, how much? B over H is equal to cot value. So we have to find this area. How to find? Now b is equal to h cot value. We have to find this. B is important here. We have to understand that this b is very important here in this case. B unknown. So b over h is cot value, that is b over h. This is b over h. Now this is base upon perpendicular, so this is reverse cot. What do you want? This is, and we can say, right. So this is F135 F135 into G135. So we got this one value. Now diagonal D1 involved base. Diagonal D1 involved base. What do you want to know? This diagonal D1 involved base. We got my point. Diagonal D1 and two diagonals are there. What we have done? A minus B. This is A minus B. That is A minus B. We can say this is A minus B. We are going to work in this triangle. Let us see. And this one, this is a different type of triangle. So what we do is, now A minus B, that is C135. C135 is A minus B, H135. This is, we got B here. See, we got this one, A minus B. This value we got here, A minus B. This value we got, okay. This value we got. This value H involved base is A minus B. We got this value. Now D1 square is equal to how much? D1 square. D1 square is how much? We got this right triangle now. So A minus B, you can say one dimension, and H is another dimension. This is square and this is square is equal to under root this square. This square plus this square is equal to this square, right? So we say D1 square, this is D1 square is equal to A minus B square plus H square, right? Base and hypotenuse, base square plus hypotenuse, base square height square, perpendicular square is equal to this square. That's formula. So we got it. This is, we got formula I-135, say I-135 diagonal square equal to A minus B, that is A minus B is here. It was therefore this is I-135 square plus E-135, which is H. So 4.8 this says. So under this square is called this answer. So what's diagonal? Under root of this J35. We got 6.27 diagonal. So we got D1 value. We got D1 value here. This we got, right? We got D1 value here. This is a diagonal D2 involved base is equal to A plus B. Now we are talking about diagonal D2. D2 is here, right? So we have to think of this, right? Though this doesn't exist, but we have to assume that. So this is what we say, A is this one plus B, A plus B, and this is H, and this we can find A plus B we have. A plus B we have, that is A plus B. You can say A plus B is here. A is C135. A is C135 plus B is H135. This is here H135. We got these two values. So we put in this, we have A plus B. We can say A plus B is here. Now diagonal square is called A plus B square. A plus B square is all this here, L135 square plus E135. E135, that is H square, and this is E, this H square 135, and we get this value. So we get this value here, and under root of this is, you get diagonal 2, right? Diagonal 2. So we got this diagonal and this diagonal. We got D1 here, and we got both diagonals we have. So other parameter, let's say 4 into A is parameter. Now we got what we want to know. Now let's go further. This is sign values as usual. Now what we say, what we have to find, diagonals we have. Now we have to find now area by geometry and area by diagonals, both we have to check. Area by geometry. Area by geometry, that is, now let's say here angle, triangle, you half into base into height, right? Half into base into height. uh, angle triangle, area triangle. I think it is wrong here. Angle triangle. This is half into base into height, and you can say this is area, and we can find other area also. So let us see what was done. Now half into base into height. So half into h135, h135, that is here. So this is value of b, right? This is value of b, and b is here. B is here, right? Half into base into height. So this is angle triangle. I have to say this angle actually, this angle we took. This name of this angle, so I'm calling this angle triangle. Angle based triangle, angle triangle you can say, means angle is there and this triangle I'm talking. So it's called angle triangle name. Let us say base, of course, okay, angle triangle doesn't have into base into height. E135, E135 is this, half into base into height. We got this. The internal rectangle is which one? So this we have to see. Internal rectangle, this triangle we got a minus b into h, a minus b into h. This is right. This is internal rectangle. Okay. A minus b. This is a minus b into h, and that is a minus b. A minus b is I135. I135. This a minus b into h, and h is E135. E135 as that. So we got this. So now total area, it is angle triangle, and then internal rectangle, and angle triangle again means the two angle triangles are there, right? Is here. This is one. This is angle triangle, and this is the reverse of that, right? This triangle is here. This is here. But we are talking. See, this is the same as if you draw it here, and we say this is triangle. So this is rectangle here. So this is angle triangle. This is rectangle, and this is another angle triangle. So there are two angle triangles here, right? This is one angle triangle, another angle triangle, same area, and this is internal rectangle. So this is total sum into this I1, I this 138 into this. This is sum here. This is by geometry. We got area. Now area by diagonals, what to do? Let's say d1 into d2 over 2. What is d1? Let us say d1 is now, this is d1, let us say this is d1, k135. K135 is this, right, into d2. D2 is n135. This is n135. Divide by 2. Divide 2. Divide 2. So this area by geometry and by diagonal is same. It comes in, and we say now pyramid. So, three-dimensional, third dimension, extrusion of that surface on planar, and area is, L138. This is L138 is area here, and height can be anything. So we can say multiplication of 2 h and I here, h and I. You get this volume, and surface area is equal to rhombus equal to area. A plus 4a is parameter to that. So areas, 2 into areas L138. That is this one. Plus O135, this is O135, this is 135, that is parameter here, your parameter. So we multiply this by depth here, and this is I144, and we get parameter here as well. So we got volume as well as parameter, and we can say this is that. So we got this one. So this is your, rhombus. Well, I think maybe a little complicated, you fail, but it's a good one. Hence, it's not bad one. Rhombus, you solved rhombus, and we based on trigonometry, we solved rhombus. Diagonal we found, area we found, and we found its extruded volume. Now we'll go to trapezium. But I think I have a problem of light here. for just 1.5 hours. I wanted to continue for 2 or 3 hours, but in this, let me see if I can continue. Let me try if I can. Trapezium. What is trapezium? First of all, you have to understand this trapezium. This is trapezium. You know that. This is trapezium. You see this trapezium. This is trapezium. This is trapezium. Sorry. This is A, this is B, and then, height is there, but here, height is there, and this is C here, which we do not know, and this is D here, we do not know. We know A, we know B, we know height. This hypotenuse and this hypotenuse, we do not know. So what to do? Now, if we know, it's okay. If you know, it's fine. Now, I'm taking first of all this as a matter of fact. I'm taking first of all this is here, and this is let's say I'm taking symmetrical. Symmetrical, I mean to say, let us consider first C and D are equal. That's called symmetry. Means center and B centered. This means B centered at A on A, and C and D are equal. That's called symmetrical. Let's take consideration of symmetrical first. If it is symmetrical, as I said, trapezium 1, trapezium 2, this is non-symmetrical. It's symmetrical, there's a bottom, base A, B, and H. Let's say A is there, 4 is there, 5 is there, height. Now, when it is said equal sides, equal projections are, on both sides A and B are same, but B centered on A. This means here projection is this and this, horizontal projection over hypotenuse, left C, and this is right on right C. So if you see just by calculation 10 minus 4 is equal to 6, so 3 and 3 should be there automatically. C147 minus 4 over 2 whole over 2, and similarly here C147 over 2. So this is symmetrical case. So we will go further on this and we will see how it works. Then we will say, we'll find here hypotenuse and other hypotenuse. Both hypotenuse will find. This is this formula. I'll explain to you later. This hypotenuse will found, and then once we know hypotenuse and this, we can say parameter we can find. There's no problem at all. That's what it is. I'm just giving you a brief. I'll explain to you later. Then other trapezium is, let's say 10 for same thing. But here we say no, I don't want symmetrical. I have to fix myself. I say 4 and 2 here. 4 and 2 here. So 1 is 4, 1 is 2. That you have to see yourself, means how it works. You have to see 4 and 2, and here, so total should be the same. So 4 and 2. So we can say non-symmetrical. So a horizontal projection over this, and again there, then this, you have to find the hypotenuse of this and hypotenuse of that, and then parameter, etc. You can find. This is another procedure. Then polygon, we have to say 5-side pentagon. The 5-side pentagon, you can see this pentagon, all sides are equal, and we have to find its area and parameter based on geometry as well as based on direct formula. Based on geometry, so these are equal. We have to check triangle here by perpendicular. We have to check angle is 108 in pentagon. This is D, this is B, this is A, this is C, like that. We have this angle 18, this angle 36, according to geometry, which worked out on AutoCAD. So this is way, we'll work on that, and also then we'll say pentagon and a lot of calculation in that, and then again we'll say this is hexagon, 6-sided. This hexagon, which is also 120 here, and we'll calculate accordingly, like that. And this is your heptagon, which is 7 sides, and then 7 sides, and then we have octagon, 8 sides. That's 7 sides, 8 sides. You can see figure here. This is 7 sides. And this is hexagon. This is heptagon, and this is your octagon, 8-sided here, and then it's 9-sided here, 9-sided, and of course there is then 10-sided here, and we'll take 11, 12 later once we understand method clearly. Only point is we have to formulate this, and we'll take other figures later, other equations later. So now I'm just explaining to you simply means what we have to do. I was late today, so I could not do it properly. I could not start video in time. The next time I'll take 2-3 hours. Probably if video works. Now it's giving zero signal. However, I'm not sure to save or not. It's giving, well, already 1.5 hours gone. So I'll take your leave now, and we'll see next time how we do it. We'll do it. How we'll do it, we'll see. That's the important point. If understanding is very important. If you do not understand, then if you do not understand basics, what is required is understanding of basic how to move on worksheet. That's most important, using trigonometrical functions as well as other geometrical functions. That's very important point here. If you understand that, we can find any solution, then whatever it is. So with this, I think there's no light in my room now, so I cannot work continuously on this. I'll take your leave, so I think it's fine. I can just browse again on this sheet if you want to see. This sheet started here. Its generation is 15/11/617. That's the today's 55/11. There are so many equations we worked out before, and then we entered some formula, and then started geometrical shapes. And this and these shapes were continuous like this, and then, well, I think it's a long way to go. I working. I did my working myself, because if you work during layout, so doing live, it takes a lot of time. So I prepared at home some work, so that just to explain to you how it is done. That's very important, And I have also browsed certain websites for this, just to see, for example, Maths World War. Many websites are there. Many equations are there that we'll see in future how to handle them. So with this, I think I should take your leave for today. It's too early to go. I wanted to plan for 4 hours, but I did not do that. I did some research. Well, I think you must find some interest in this. It's an interesting one. If you do yourself, it's fine. Okay, then I hope that you understand. Main thing I say, procedure is important on worksheet. Your mind concept is important in worksheet. What do you think about that? That's important. It can be done this way or that way. What's important is we have to understand sequence. We have to understand how to use cells of worksheet. It's not difficult, and also it's not easy. It's not general calculation. I'm giving you account balance sheet or salary sheet. I'm not giving that. That's available everywhere. We are talking in engineering terms. We are using engineering here. So that's very, very useful in our career, in our work. Engineering mechanism, engineering calculations, engineering formula are very, very important here. That's point here. So जला देना, एक स्विच जला दो इधर से, मैं जला एक स्विच ऑन कर दो ना, इधर वाला, लेफ्ट वाला, राइट वाला. अरे कहाँ समझते हो? हाँ. So you can browse on this sheet and see if it's something. अरे कहाँ का किया है इसने यार? Well, इधर का कहा था मैंने, तो एक दबा दो इधर का. हाँ, बस हो गया. Oh, so I just put it as well. Well, I'm not getting light on my keyboard and computer. Well, it's fine. It's okay. Just important thing that today we discussed is we discussed previous one, and we talked on this formula. But we started actually from here. We refreshed the squares, rectangle, triangle, ordinary, equilateral triangle, isosceles triangle, right angle triangle, triangle three sides, and circle, as well as sphere, hemispheres, cylinder, hemisphere, cylinder, cone, and then we entered our parallelogram. So we worked on parallelogram, rhombus, and we worked on trapezium 1 and 2, and polygon we started. So this is what we could do today. I think I'll take your leave now, and thank you very much. I'm going to stop this hearing.